Hello and welcome to helpyourmath.com. In this video, we are going to look at applications of percents, and there's an 85% chance you're going to love it. I want to start with just an example, even though these are fractions and not percents, but we'll get to why maybe percents would have been better. So during the 1980s, after the Big Mac came out in 1972 and was immensely popular, another burger chain called A&W, you might know them now as their root beer brand, they tried to launch a new burger, and it was the Third Pounder. In taste tests, it outperformed McDonald's Quarter Pounder, and it either cost about the same or even slightly less. But it failed epically. Why? Well, it turns out fractions are hard. So A&W said, yeah, we have a third of a pound. And McDonald's said, yeah. Well, they didn't say anything. They didn't have to say anything. The Quarter Pounder sold itself, but it's a quarter pound, 1/4 of a pound. When people were interviewed as to why they chose the Quarter Pounder, they said, well, because 4 is bigger than 3. Looks like we needed some help with math back in the 1980s. Two different ways we could show just how miserably wrong that is we could just get them to have the same denominator, because we can compare numbers more easily when they have the same denominator. The best denominator to use here would be 12. We could multiply 3 by 4 and then 1 by 4. So 1/3 would be 4/12 versus 1/4, if we multiply by 3 over 3 to give us that denominator of 12, is 3/12. Now you can make the argument 4 is bigger than 3 and be correct. But where does the 4 belong now? To that third of a pound. Also, if A&W had just did a percent instead of a fraction, maybe they would have had better success. Because 1/3 of a pound, that's 33% of a pound, versus 1/4, which is 25% of a pound. I have seen articles recently that A&W is trying to earn their reputation back. Even 40 years later, they're still struggling. So let's all cheer for them, and maybe let's all review our fractions before we make some leaping conclusions. Okay, so next up, there's some data out there, and the numbers are kind of all over the place, but I tried to just blend all the data I found, and I figured out that about 14% of the population is left-handed. So if you're in a room with 46 people, then how many people in the room should be left-handed? What we're looking at is 14%, we're going to assume that this statistic applies to this room full of people, of the number of people in the room of 46. Well, as you may have heard in my previous videos, we can't, as much as we like percents and it makes sense to us, we can't use them in mathematical problems. So what we need to do is either convert it to its equivalent fraction or decimal. Whichever one you decide, you have to divide it by 100. For this, usually it is going to be a little bit easier to use the decimal, because I will pull up a calculator and we'll use the calculator. And the decimal equivalent, we would divide by 100. That moves the decimal point 2 places to the left. So we get 0.14, or 1400ths, of, in the situation of like a fraction of a population, translates to times, and then 46. And then this is going to tell us the approximate left-handed people in the room. So this would be a good point if you don't already have a calculator. I do suggest doing the calculations with me to make sure that we all agree with the answers. So I'm going to pull up my calculator. Okay, so I have my calculator, and what I'm looking at is 0.14 times 46, and I get 6.44. When I do this, I get 6.44. It would change back to red. That's okay. However, we don't have fractions of a people. There's not like a 0.44 of a person who's left-handed, and you could be ambidextrous, but that's not what the question's asking. So we would use our rounding techniques. We would round to the nearest person, right? Because again, there's no fractions of people. And this 4 in the 10th place tells the 6 to stay the same. So we could say probably 6 people would be left-handed. Probably 6 people. And that would be my final answer. Okay, next up, to win the presidential election in the United States, a person must obtain at least 270 of the 538 possible votes from the Electoral College. What percentage of the overall electoral votes is this? In this case, we're not given the percent, right? In the last example, we were given the percent. We had to apply the percent. Now we want to know what is the percent. So we're going to look at the 270 is the portion that we need out of the total 538. So this is the fraction we're looking at. Then to convert a fraction into a percent, we would multiply by 100%. So I'm going to say times 100%. And again, I'm going to do this in my calculator. When I type this in my calculator, the fraction bar, we use division. So in the calculator, I'm going to say 270 divided by 538. And then I'm going to multiply by 100, and I'll add the percent when I'm writing the final answer. Okay, I have my calculator. It still remembers the last calculation. Excellent. We're going to type in 270. I'm going to do divided by 538. It's always numerator divided by denominator. Then I'm going to convert it. So that's the decimal. I want to convert it to the percentage. And I can't see it. Let's see. It looks like 50.19. 50.19%. I use the squiggles because that's approximately, right? It was a decimal that had a lot of digits that appeared to never end. So what percentage is this? It looks like it's just above half. It doesn't indicate where to round. I rounded to the nearest 100th of a percent. That's probably good enough. So it looks like to win the presidential election, you just need just more than half of the Electoral College to vote for you. Okay, in the next example, for a single filer earning between $41,776 and $89,075, this person must pay 22% in federal taxes. So this is, April 15th rolls around, you have to file your taxes. Usually you're paying a little bit with every paycheck, so hopefully, April 15th, you're not getting slammed with a huge 22% fee, because that would be not ideal. But let's see what Penny's doing. So Penny is a single filer. Penny earns $56,100. So how much is Penny going to pay in federal taxes? Because she falls into this bracket, she must pay 22%. So just like we saw 2 examples ago, what we're looking for is 22% of her salary, $56,100. Again, in the calculator, I can't type in 22%. I'm going to convert it to its equivalent decimal, move it over twice, and I get 0.22. Of means times, and then we have 56,100. Let's see what the calculator says. I have it on this side just so I can see it. I'm going to type in 0.22 times 56,100. And in this case, it doesn't necessarily have to tell me. Oh, and it's a perfect number. Well, in that there's no repeating decimal or anything. If there was, or even if it went to like the thousandths place, we would round to the nearest penny because we are talking about money. But it looks like we just get a flat $12,342. And we're going to write that $12,342. So throughout the year, hopefully not all at April 15th, but throughout the year, Penny's going to be paying a little bit of this to the federal government as we go through the year. Up next, we have Andrea and Russ. Andrea and Russ are looking to buy a house. They have $120,000 saved up for a down payment. New Jersey lenders requires a minimum down payment of 15% of the value of the home. So, based on this, what is the maximum home value that Andrea and Russ can finance? Now, keep in mind, this is just the upper limit, but you should never, you don't want to do your absolute upper limit, but if it's your dream house, you have to do what you have to do. Okay, so in this case, this one's a little bit different than what we've seen before, because what we have here is we already have the 15% of the value of the home. What we don't know is the value of the home. So we're going to set up the equation here. 15% of that upper limit, I'll use H for home, we know what the answer of this is. We know this is going to be $120,000. And now we're going to convert this. We're going to turn this into a little equation, 15%. That's the equivalent, because I'm dividing by 100 of 0.15. Of becomes times, and then we have H, 120,000. To get H by itself, I'm going to divide both sides by the 0.15. And because I'm dividing by something smaller than 1, this is going to give me a number way bigger than 120,000, which it should, because 120,000 is only 15% of this number. So we'll pull up the calculator, and let's see what we get. 120,000 divided by, right, we're going to use the division symbol, and then we're going to do 0.15. And their absolute upper limit is 800,000. So when they're searching for their home, they should be looking for houses that are at most 800,000. All right, always something to look forward to, health risks. Jay has to monitor his carb intake. He has a bowl of oatmeal which contains 18 grams of carbs. That's about 20% of the recommended daily amount of carbs that Jay should consume. Based on this, how many grams of carbs should Jay consume daily? Again, just like with the housing example, the 18 is the 20%. What we don't know, the unknown here, is the recommended daily amount of carbs. We can set this up just like we did with that last one, 20% of the, we'll just say, we'll use R for RDA. We know what this equals. This equals 18 based on this scenario for J. Converting this into an algebraic equation, 20% divided by 100, we get 0.2 of, we're going to rewrite as times, and then we're going to use that variable because we don't know what it is. To get R by itself, we'll divide both sides by that 0.2, because 0.2 divided by 0.2 is 1, and 1 times R is R. Pull up the calculator to do 18 divided by 0.2. We have 18 divided by 0.2. And again, this number should be bigger, right? Because 18 is just a piece of it. It looks like Jay could have up to 90 grams of carbs. We're going to write in here 90. And you can do a full sentence. I just can't write very neat on here, but I'm going to say 90 grams of carbs. And that would be my final answer. A tablet is priced at $1,199 and it's on sale for 30% off. Yay! New York City sales tax is 8.875%. Find the sale price of the tablet after the discount and including, let's move the including over here, including, oh, I see, it's fine. After including the discount and the sales tax. I at least will put the S in there for sales tax. Okay, fabulous. We have two different things that we're looking at. So we're going to start with the discount because the tax that you're going to pay is dependent on the price that you pay. You don't pay the tax on the original amount, you pay it on the sale price. So let's start with the sale price. There's two ways that we can deal with a sale price. One thing we can say is, well, if it's 30% off, we assume that the cost is 100%, then we can deduct the 30% now, and we can say, okay, well, the sale price is going to be 70% of the original price. I like this because that's an easier subtraction than if we do the 30% and then take that amount and subtract it. But either way, we're getting to the same answer. So I'll do it this way and then I can show the other way as well. If we look at the sale price, so we're paying for 70% of that full price of $1,199. Converting this to its equivalent decimal is 0.7 times 1,199. We'll pull up that calculator and we have 0.7 times 1,199. So the sale price is $839.30. $839.30. Okay, so that's the sale price, but that doesn't include the tax. So the other thing we could do is we could do 30%. We could figure out how much exactly we're saving. 30% of 1,199. Its equivalent decimal would be 0.3 times 1,199. And when we do that, we have 0.3 times 1,199. So we'd be saving $359.70. Then what we would do once we know the amount we're saving is we would take that and we would subtract it from the original amount. We would say 1,199 minus, I can't see the saving, my thing is blocked, there we go, 359, I missed it, didn't I? 359, there we go, 0.70, and there it is, $839.30. So either way, it doesn't matter. We're still going to get to the sale price of $839.30. But notice whichever way, there are two steps. You have to subtract and you have to multiply. Turns out the order of the two doesn't necessarily matter, but you have to do both steps. Okay, and now to put the sales tax back in. So sales tax gets added on to the price, right? So it's going to make the price go back up. And again, just like with the sale price, there are two ways we can figure out what the total price will be for this tablet. One option is to just calculate the sales tax all by itself, and that would just be taking the tax rate, 8.875% of the the price that we're paying, $839.30. We would convert this to its equivalent decimal. This is kind of an awkward one. It goes deeper into decimals, and that's okay because it should be getting smaller. It's the decimal version, times 839.3. We will probably have to do some rounding here. Let's see what happens. Okay, I've got my trusty calculator. I'm doing 0.08875 times 839.30 cents. I don't need that last zero when I'm doing the calculation. Yeah, I'm going to have to round this. It's going to be $74.49. $74.49. That's the sales tax. So the total, finally answering the question, would be the sales tax, $74.49, and adding it on to the $839.30. I'm going to do this in my head, so bear with me for a minute. 49 plus 30 is going to be 79. So the cents is 79 cents. And then we have a 3 here and a 1 here and a 9. I'm getting $913.79 is the total I'm going to end up paying. And I'm going to check my work because as much as I trust my arithmetic, I don't trust my arithmetic. Okay, so what's the other option? Well, here we multiplied and we added. And just like with the sale price, we can do the two things in either order. So I can say, well, the sales tax, I'm paying 100%. So we have a new 100% when we do this. And this is the sale price because this is the amount we're paying. Plus the sales tax, 8.875%. So the grand total I'd be paying for this, sales tax included, is 108.875% of the price that I would be paying of the $839.30. So then to convert this percent, this 108%, into a decimal, I would again divide by 100, move it over 2 times, and that would be 1.08875, that's a 5, times 839.3. And this should match what we got. Let's find out. Because unlike that gentle addition, I'm not about to multiply this in my head or even show all the steps because that would take a long time. 8875 times 839. Oops, I missed the 3. 9.3 and 913.79. Confirmed. That's the amount we're paying for this tablet. It's going to change back to red. I'm putting a check mark. Confirmed. These have been examples of applications of percents. Thank you for stopping by.